In this presentation, we will learn how to reverse the complete doubly linked list. So let's get started. Suppose this is the initial state of the doubly linked list. Currently, these are the elements of these nodes. Head pointer is pointing to the first node. Now, we want to reverse this complete list so that this node becomes the first node of this list, this becomes the second node, and this becomes the third node of this list or the last node of this list. For this purpose, we will update the links of these nodes. First, we will update the next part of this node so that it can point to this node, and the prev part must contain null because this is the first node of the list, right? So prev part must hold null and next part must hold this address 2000. We must have to update the next part of this node so that it can point to this node, and prev part of this node must be updated so that it can point to this node. And then finally we have to update the next part of this node so that it must contain null, and prev part of this node must contain this address 2000 because we want that this node must point to this node, right? This is the required state we want. Now in order to obtain this state, we have to perform certain procedures. First, we will keep two pointers, ptr1 and ptr2. ptr1 must point to the first node of the list and ptr2 must point to the second node of the list. For this purpose, I'll put this piece of code, that is ptr1 equal to head and ptr2 equal to ptr1 next. After this, we will try to update the next and the prev part of this node using ptr1. Let's just try to update the next part and the prev part of this node. First, we will update the next part of this node so that it must hold null, right? Because this is going to be the last node of the list. Next part must contain null according to the required state, right? So we will put null over here. After putting null, we will lose the reference to the second node, but please note that ptr2 is already pointing to this node, so we will never lose the reference. So we can easily place null over here. There's no problem. After this, we will try to update the prev part of this node so that it can point to this node. For this purpose, we will put this line of code, that is ptr1 prev equal to ptr2. You can see over here, this is now replaced by 2000. That means this particular node is now pointing to this node. This procedure is done, right? Using just ptr1. Now, we have to update the next part of this node and prev part of this node. Obviously, we can see over here that ptr2 is already pointing to this node. Let's try to update the prev part and the next part of this node using ptr2. First, we will try to update the prev part of this node using ptr2. For this purpose, I will use this line of code. ptr2 prev equal to ptr2 next. We can see over here, according to the required state, this must contain the address 3000. 3000 is the address of this particular node. That means we need ptr2 next. What is ptr2 next? ptr2 next is 3000. So we'll place this over here. Now, we have to update the next part of this node. Can we update the next part of second node? Now this is my question. Okay, can we update the next part of the second node? Is it not the case that we will lose the reference to the third node? No, my dear friend. We will not be able to lose the reference of the third node because we already have the reference to the third node. We can see over here that prev part is already holding this address 3000, right? We will never lose the reference to the third node because we already have this address. Therefore, we can definitely update the next part of this node by using ptr2 because we already have reference to the third node. Now we will use this piece of code, that is ptr2 next equal to ptr1 in order to update the next part of this node. This particular node must point to this node. That is why 1000 must be placed over here. We can do this by putting this line of code. ptr2 next equal to ptr1. We know that ptr1 is holding this address 1000, right? That is why I'm using this line of code. After this, we have to move our pointers towards right. For this purpose, first we will move our ptr1 so that it can point to this node, and then we will move our ptr2 so that it can point to this node. How we will move ptr2? We can move our ptr2 pointer by using ptr2 prev, right? So ptr2 is equal to ptr2 prev. Now ptr2 is pointing to the third node of the list. Now our next job is to update the third node of this list. For this purpose, we will repeat the same piece of code which we have already seen. We will first use this line of code so that we can update the prev part of this node. ptr2 prev equal to ptr2 next. We know that ptr2 next is null, so we'll place null over here. After this, we will use this line of code to update the next part of this node so that it can point to this node. ptr2 next must be equal to ptr1. We know that ptr1 is already pointing to this node and ptr2 is holding this address 2000. Therefore, we can place this address 2000 over here. After this, we will update our pointers, that is ptr1 and ptr2. First, we will update ptr1 so that it can point to this particular node, And finally, we will update ptr2 so that it can point to the next node, and we do not have any other node in this list. Therefore, this address will get replaced by null, right? We know that ptr2 prev is null. Now when we should stop? When ptr2 becomes null? We know that this piece of code will get repeated, right? Therefore, when ptr2 becomes null, we should stop. So we should stop over here. So we will keep this under this while loop, and we will put this condition. If ptr2 is not equal to null, then only we will be able to evaluate this piece of code, else we'll get outside of this loop. It is as simple as that, okay? This is the complete procedure I have written over here. We have these two pointers ptr1, ptr2 declared. Initially ptr1 is pointing to the first node and ptr2 is pointing to the second node. We will use this piece of code outside of this while loop to update the links of the first node, okay? We can see over here this piece of code is outside of this while loop because this piece of code is helping us to update the links of the first node only, right? Links of the second node will get updated using this piece of code. That is why I have put this under this while loop. And this piece of code must be outside of this while loop. Using this piece of code, we would be able to update the links of the first node. And using this piece of code, we would be able to update the links of the other nodes of the list. Finally, we will update the head so that it can point to the last node of the list. And then we will return head. Now, we will see the complete code in code blocks. Here you can see this is the complete code. Struct node is declared, add to empty function is written, add at end function is also written. Then we have this print function, and finally we have this reverse function, which is similar to what we have seen, right? We have this main function also, again the same thing, that is add to empty function is called to create the first node of the list. These two add at end functions are called to create the other two nodes of the list, the last two nodes of the list, right? Printf function is called to print this message before reversing the list. That is, I want to print the elements of the list before reversing it, okay? That is why I've called this print function. And after this, we will call this reverse function to reverse the list. And after this, we will print this message after reversing the list. And then we will call the print function to print all the elements of the list after reversing. Let's just execute this code. You can see over here, before reversing the list, these are the elements 34, 45, and 9. After reversing the list, these are the elements of the list 9, 45, and 34. You can see the list is now reversed. Okay friends, this is it for now. Thank you for watching this presentation.